Good morning everyone. Today we are going to study about the subject computer graphics. I am sharing my presentation here. In computer graphics, we are discussing about the first unit, that is the graphics primitive and its algorithm. First of all, we will try to understand how we are going to represent the pictures on the screen. So many algorithms are using for accepting the picture data as a polygon or the edges, and each polygon or edge can be turned by representing the points. For example, the image or a block is drawn on the screen, and this particular square box is having their own coordinates. For example, P1 is having the coordinate that is 0, 0. It is the origin coordinate. And the next coordinate is P2, which is 1, 0. That means it is incremented with respect to the x-axis. In the similar way, we are having P3 and P4. P3 is the point which is incremented with respect to the x and y axis. That's why we are having the coordinate 1, 1. So the points that are the fundamental building blocks of the picture representation. If we are not having the points, so we cannot able to build any kind of the polygon object. So in this square, we are having the 4 points and we are having the 4 edges that can be represented here. Next, information is generally stored in a file before it is used to present the picture. That file is called the database. That means we are going to store the coordinates of each point of a particular object in a tabular form that is called as a lookup table, or we can say that it is a database. There are the two ways to specify the position of the points, that is the absolute coordinates and the relative coordinates. So basically we are going to work on the absolute coordinates, but we should understand what are the basic difference between absolute coordinates and the relative coordinates. So absolute coordinates are the location which we are going to specify as a relation to the y axis or y origin. And the relative coordinates are the location that can be specified to the relation that are good for the pen and plotters, publishing or layouts, and allows for the very object oriented approach. For example, if we are drawing any kind of object using the graph paper, using your pen and pencil, that is called as the relative coordinates, and it is quite easy to draw on the graph paper. But while we are considering the graphics or the plotting of an image or object on a particular screen, so we have to first of all consider the origin of the screen, as well as we have to perform so many operations on the particular object. For example, transformation operations, that is the translation, rotation, scaling, and others. So for this, we have to perform the operations. We have to consider the origin with respect to the particular corners. So that's why we are working always on the absolute coordinate. So we can translate or we can shift any kind of the object with particular coordinates to the origin coordinates. Okay. So we are going to use the absolute coordinate for our further studies. So you can see here, these are the particular coordinates of the our rectangle. Okay, now we should understand how the interactive graphic display works. So if we are looking at the particular screen, we are seeing, so how this particular interactive graphic display works. We should understand how this particular pixels or the image, it is going to be displayed in a continuous manner. So there is a background working process in this. We require a digital memory or the frame buffer, which is going to store all the images intensity in that particular tabular form, and a monitor which is going to display the particular image, as well as the display controller which is giving the particular rights at particular time you have to display the image. Inside the frame buffer, the image is stored as a pattern of the binary digital number, which can be represents a rectangular array of the picture elements or the pixel. Okay. So now we are going to understand about the pixel, that is the smallest screen element. We have to understand about the pixel, then only we can able to understand about the resolution and other things. So we cannot represent an infinite number of points on a computer. We are having a finite number of cells, and a particular cell we can plot a particular pixel. Okay, so we must build our line from a finite number of points. Each point must have some size, so it is not really a point at all. A pixel or a picture element, which is called as the smallest portion of an image that could be displayed on the computer or a print on a printing display. Okay, each pixel is a sample of an original image, because with the combination of number of pixels we can form a complete image. So you can take a consider example. In our first diagram we have drawn the number of cells, which is a combination of horizontal and vertical line, and in that at the position of 6,4 we have plotted a pixel which is of represented in a black color. And the second picture, it is of a colored image, which is a combination of number of colors, and we can able to see each and every pixel, it is in a different form, it is in a scattered form. If we are going to increase any resolution of the particular image, the particular object will be of a smaller size and it is of clear form. Okay, so this is a picture element, or we can say the pixel. This is a best example that the smiley we are going to use in our phones or everywhere for a particular representation of emojis. So this smiley has been created and it is enlarged with a particular thing, so we can able to identify each and every pixel plotting. We can able to see how it is has been plotted. Okay, so if that particular emoji is seen in a very smaller part, or we can say it is of smaller size, so it looks like very clear image, but while we have zoom it can be able to identify that the pixel how has been plotted on this. Okay, the next one is the refresh buffer. How the refresh buffer is used, why we are using the refreshing buffer. Refresh buffer is responsible for updating the content of the pan or the window which we are seeing right now, and automatically or the manual refresh is performed. For example, this screen is visible to us, but this screen on a background purpose, we are continuously refreshing the frame buffer, and it is representing the particular intensity on the particular pixel location so that the image can be displayed in a continuous manner. Refresh rate is the number of the times per second that the pixel recharge so that the glow remains bright. In the dual screen, if we are having a dual screen, that means we require the more refreshing rate speed. So at the time we are using the two refresh, or we can say that the frame buffer. That means the top and the bottom of the screen are refreshed independently at twice the rate of single scan screen, producing more clarity and richer colors. Okay, so the display are refreshed with the rate of the 45 to 100 times per second. Last is a frame buffer. Frame buffer is used for storing the pixel intensity, as we have discussed. This frame buffer is a part of the RAM of the system, which is used to store the bitmap file, is responsible for displaying any image or the video. In the other words, we can say that the memory buffer that accommodates a full data framework, that is called as a frame buffer. So this frame buffer or the frame work which is you going to use for storing each and every pixel intensity before displaying on the monitor screen. That frame buffer is used for storing all the pixel values. That is we have used. So there are some references we can use for the pixel for understanding. So we can see the pixel. Okay, so pixel in computer graphics, sorry. Okay, so you can see here, you will get this few images to identify how the pixel is going to work and how pixel is working. Okay, so we can able to identify this is a pixel, this is a particular image of a particular bird, and we are just zooming out the eye of a particular bird. So we can see like this, we have zoomed and identified this particular eye color is also having different color combination, and this is a 1 pixel. In a particular lotus flower also, we are identifying the number of pixels in this. Okay, this is a just example we are looking at. And if we want to understand about the resolution in computer graphics, we can able to understand this also. That indicates the number of pixels that are displayed per inch of an image. Okay, most computer monitor display at the resolution of 72 pixels per inch or 96 pixels per inch. So this is, we can understand, this is a 720 pixels, 1080 pixels, and 4K, that is we are using nowadays. Okay, the standard display resolution high definition is 1280 cross 720, full HD is 1920 cross 1080, And if 2K or 4K, it is more resolutions we are having, that is 2560 cross 1440 or 3840 cross 2160. Okay, so this is about the resolution. Okay, so you will get few definitions of the resolutions as well. The resolution is defined as the number of dots per inch or centimeter that can be plotted horizontally or vertically. Higher the resolution, smaller the spot size. Resolution is related with the quality of the graphic system. Higher the resolution, better the graphic system, as I have discussed with you. High quality resolution is 1280 cross 1024. As per the requirement of our usage of our televisions or the laptops, the resolution of our screen can be increased or can be decreased, depends on your purchasing. Okay, that's all for the today. Thank you so much. Thank you.